All right, guys. So the next question, you can just give it a try and then you can resume the video for its solution. So bottle 1 contains a mixture of milk and water, okay, in the ratio 7:2. All right. So I'll write it as bottle 1 or B1 contains milk and water in the ratio 7:2. Bottle 2 contains a mixture of milk and water. Milk is to water. The ratio is 9:4. In what ratio of volume should the liquids in the two should be combined to obtain a mixture of milk and water in the ratio 3:1? Typical question of alligations, guys. The first bottle contains milk and water in the ratio 7:2. So now, if I ask you in bottle 1, what is the fraction of milk in the total solution? Okay, if you remember your ratios, the fraction of milk in the mixture is 7 upon 7 plus 2, that is 9. So 7 by 9th of the mixture is basically milk in bottle 1. Similarly, in bottle 2, the fraction of milk will be 9 divided by 9 plus 4, that is 13. And the final mixture that you want, the mixture contains milk and water in the ratio 3:1. So what is the fraction of milk in the final solution? 3 out of 3 plus 1, 4, 3/4. So now let's consider the alligation between 7 by 9th of milk in the first bottle, 9 by 13th of milk in the second bottle, and 3/4 of milk in the final mixture. We have to use the rule of alligation. So what we can also do is we can already take the LCM, the least common multiple of denominators. We have 9, 4, and 13. So here multiply by 13 into 4 above and below. Same thing you can do here. Multiply by 9 and 4 above and below. And here you can multiply by 13 and 9 above and below. So as you can now observe, guys, the denominators have been made equal. And once you make the denominators equal, you can directly cancel them out, because once you subtract them using the rule of alligations, the denominators will obviously get cancelled out. So I can now only focus on the numerators and write the alligation with respect to them. So 7 into 13, 91 into 4, bottle 1 contains 91 into 4, 364 units of milk. Out of the total, bottle 2 contains 9 nines are 81 into 4, 324 units of milk. And the final mixture contains 39 into 9. That is 40 minus 1 into 9, 351 units of milk in the final mixture. Now applying the rule of alligations, 364 minus 351 is 13, and 351 minus 324 is 27. Okay, the ratio that we need is 27:13. Right? This is one way of solving the question using the fraction of milk. Now we can also use the alligation method, guys, by taking the alligation with respect to water content. In the first bottle, water is 2 parts out of 9. So the fraction of water in the first bottle is 2 by 9. Similarly, in the second bottle, the fraction of water is 4 out of 4 plus 9, 13th. And finally, the fraction of water is basically 1 out of 1 plus 3, that is 4. So 2 by 9th of water in the first bottle, 4 by 13th in the second bottle, and the final is 1/4. Okay, once again, make the denominators same. So multiplying above and below by 13 and 4 in the first case, denominator should be same. LCM of 9, 4, and 13, right? So 13 gets multiplied by 4 and 9. 9 into 4. Even above, we have 9 into 4 getting multiplied. And here we multiply by 13 into 9. So 13 into 9. Once again, your denominators would get cancelled out. What remains is like the numerators. 13 into 4, 52, double is 104 units of water out of the total. Again, 4 fours are 16, 16 nines are 144 units of water in the second bottle, and 13 nines are 117 units of water in the final mixture. Using alligations, 144 minus 117 is 27. 117 minus 104 would be 13. Again, we get the same answer, 27:13. All right. Very simple question based on the rule of allegations. I hope this is very clear to everybody.